Good morning to another present over here. So today topic what we are going to see about Abina strain gauge. Okay. So strain gauge already we are seeing a second unit. Anyway, we'll be recollecting all the things that what we are known already. Okay. So when you are saying about an strain gauge, actually it is an electrical transducer. Okay. And it is used to measure mechanical surface tension. At the same time, it can detect and convert force or small mechanical displacement into electrical signals. Okay, so a strain gauge is a device which is when subjected to some force results change in the resistance of the material. Okay, the changes in resistance is measured in terms of either load or displacement. Okay, so on the application of force, a metal conductor is stretched or compressed. Its resistance changes owing to the fact both the length and diameter of conductor change. Also, there is a change on the value of resistivity of the conductor when it is strained, and this property of the metal is also called piezo resistive effect. Okay, it basically measures strain on the application of stress. Strain gauge directly is used for the measurement of load, and indirectly it is used for the measurement of displacement. Before going into a theory of strain gauge, so the thing is to be that resistive strain gauge, which is also known as an piezo-resistive gauges, the strain gauges which are used for measurement of strain and associated stress in exponential stress analysis. Secondly, many other detectors and transducers, for example, the load cell, torque meter, flow meter, accelerometer, which employs strain gauge as a secondary transducer. Okay, so in order to study about a theory of strain gauge, the first thing we have to know that the changes in the value of resistance by the application of force, which can be explained by the normal dimensional changes of elastic material. If a positive strain occurs, so automatically its longitudinal dimension will decrease, while there will be a reduction in the lateral dimension. If the reverse happens for a negative strain, since the resistance of a conductor will be directly proportional to the length and inversely proportional to the cross-sectional area, the resistance will get changes. The resistivity of a conductor, which is also changed when it is strained. So that is why this property is known as an piezo-resistive effect. Okay. So let us take a wire of having a length L and cross-sectional area A. So in order to consider that, we have to consider a strain gauge, which is made up of an circular wire. Okay, the wire will have the dimensions. So what are all the dimensions we'll have over on it? We'll have a length L and the area to be A, and we'll have a diameter D, so which is before being strained. Okay, and the material of the wire which will have a resistivity rho. So if we are finding the resistance of an unstrained gauge, so what will happen? So rho will be, there is a resistivity will be, resistance will be proportional to the length and the area of a cross section. So in order to remove the proportionality constant, we'll have a resistivity value rho. Okay, so let me think that a tensile stress, there is a tensile force F will be applied to the wire. So this produces a positive strain, causing the length to increase and area to decrease. So we asked geometrical. So del L or del, which is to be given as an changes in length, and del A changes in area, del D changes in diameter, del R changes in resistance. Okay, so the resistance is given by R is equivalent to rho L by A, where rho stands for an resistivity of the material, L stands for an length of the material, and A stands for an cross-sectional area of a material. Okay. So now, in order to find how del R depends upon the material physical quantities, the expression for R, which has to be differentiated with respect to S. So what will happen? So dr by ds, so it is divided with respect to an du by dv. So we will be taking that u into dv minus v du divided by v squared. So we will be differentiating according to that expression. So we'll have the expression of an a into rho of dl plus L into d rho minus rho L into dA divided by r a square. Okay. So apart from that, we are in need to find out the what are all the components that is to be given as an axial strain. So axial strain, which is given for an sigma A is equivalent to the axial A is equal to sigma is equivalent to dl by L. Okay. And similarly, the transverse strain, which is given as an epsilon t, which is equivalent to dd divided by d, is equivalent to 1 by 2 of dA by A. Whereas when we are defining the Poisson's ratio, so it's